Hello, this is the post lab for experiment 2, which is on measuring devices. So before we discuss our answers here, note that experiments 2 and 3 are divided into different sets, 4 sets in particular. So since each set has a different answer, we won't go over experiments 2 and 3 in as much detail as we did with experiment 1. So instead, what I can do is show some sample calculations, and I think Uvle should tell you the correct answers, or at least which answers you will get wrong for your measurements. I'll focus more on universal data, which is your answers that are shared between all the sets. But I'll still go over set A's answers here. Okay, so just to refresh our memories on how these things work. So we have your least count, which is the smallest quantity that a device can measure. For an analog device, the uncertainty is just half the least count. And for digital devices, the uncertainty is equal to the least count unless specified. So kapag walang sinabi, yun lang susundan natin. So again, we have different scales of measurement, which are your main scales, which is the largest scale, which is usually the least precise also. You have your fractional scale and estimated scale. Your fractional scale is an additional degree of measurement. And in this case, for this experiment, only our 2 calipers have fractional scales. As for the estimated scale, as the name implies, it's only estimated. So dito na pumapasok yung sa experiment 1 na posibleng sources of error kasi it is based on the judgment of the experimenter. So again, we have your ruler, vernier caliper, and we have your micrometer caliper. So let's do some sample measurements using our ruler first. So sa ruler natin, let's go to our data set. Oh, this should be set A. Okay. So set A, we have your ruler, vernier caliper, micrometer scale, and digital weighing scale. So for our rectangular metal sample, let's look for a ruler measurement. Yan. So as I said dun sa mismong meeting natin, a good way to do this experiment is by zooming in para makita natin in detail, more detail. Well, masyadong zoom na yan. We can see in more detail kung ano ang measurements natin. So again, one end of the rectangular cube sample is at 0. The other end is, this is 1 centimeter. So this is around 1.5. Or since nasa millimeter scale tayo, that's 15. So next, let's measure using our vernier caliper. So let's measure another dimension. We have a main scale measurement of, saan tumatapat? Sa 0. Oops, it looks like we have to zoom in further. So nasa bandang ito 20, 21, 22. Oh, kita natin dito. It's close but not quite at 23. So that's why we have to write the length measurement as 22. So let's take note of this so far. Main scale is 22. That's millimeters. So what about our fractional and estimated? So the fractional scale measurement is saan tumatapat ang line na ito. So again, our fractional scale, each line corresponds to 0.02 and there are a total of 50 lines here. So we look 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 lines. So saan siya banda tumatapat? So makita natin, banda saan? Okay, so in this particular case, walang particular lines na nagtatapat between the fractional and the main scales. So, kita niyo dito, it's at 0. So, okay, so since it looks like walang nagtatapat, this is a bad example. So, the measurement is just basically 23 after all. So, barely dumikit siya dun sa line, pero ito yung 0 line, yung pinakamukhang nakatapat. So, we can write this as 23 millimeters. So the uncertainty is half the least count. The least count is written here already. So your measurement should actually be 23 plus minus 0.01. So let's take another example. So ibang trial na lang. Hanap tayo ng ibang trial here. Na measured na, ayan. Okay, let's look at this one. Okay, so for this example here, this is trial 1. Okay. My main scale measurement is 22. Hindi siya umabot ng 23. And my fractional scale lines dito tumatapat sa 45th line halos. So again, this is part of my judgment. So that is 45 lines times 0.02. So that's 0.9. So that's 20. My measurement is for this case is 22.9. So that is main scale plus fractional scale. How about my estimated? So sabi sa manual, ang estimated ay for my vernier caliper ay wala. So my measurement for this particular trial is 22.9. Okay, next, let's go to the measurement using a micrometer caliper. Oops. Okay. Kahit hindi nakasulat, but according to the manual, the least count of your micrometer caliper is 0.01. So again, we want to measure your rectangular sample using your micrometer caliper. So let's zoom in again. So anong measurement ang makuha natin dito? Well, again, ang main scale natin, the top set of bars is an integer and bottom set is half integer. So 5, 10, 15, 20, 21, 22, 23. Take note, wala pa siya, di pa lumalabas yung next na line dito halos. So that is just 23 and not 23.5. Our main scale measurement here is 23. That's millimeters. What trial is this? This is trial 2. Okay. So next, what is my fractional scale? So dito sa horizontal line ko, nakatapat pang ilang line? So I have here my 0. So 1 line, 2 lines, 3 lines, etc. So nandito sa may banda, ito yung 45. So this is my 46th line. So fractional scale, 46th line. To get the fractional scale reading, this is 46 times 0.01 millimeters, which should be equal to 0.46. So my main plus fractional scale is 23.46 millimeters. And saan ngayon pumapasok yung estimated scale ko? Ang estimated scale ko ay ang tansya ko na distance between any two lines. Pero since saktong nakatapat, well, sa tingin ko sakto, ang 46th line sa horizontal line, this means I don't have a estimated scale reading. So that's just my reading, 23.46. So now, let us move on to our other sections. So we should thus get a set of answers for set A of the following. So these are all determined through measurements. Ang uncertainties natin ay half the least count. So ang micrometer caliper uncertainties natin ay pare-parehas lang. ang least count natin according to the caliper itself is 0.01. So kalahati nun ay 0.005. Similar sa vernier caliper, sinabihan tayo na 0.02. Kalahati lang niya yung uncertainty and ganoon din sa ruler. So ang measurements dito sa ilalim ay average. So to determine this average, we use experiment 1 techniques. So since we already have a post lab for experiment 1, I won't go over this process. Now, as for the mass of the weighing scale, ang uncertainty niya, kasi siya ay isang digital device, it's just at the same decimal place that is last determined. O kung hanggang saan may significant value si central value. So, let's go to our data set. Dahil digital tayo, you just read it. That's it. Babasahin lang. 20.7 plus minus 0.1. So that's how you measure the mass. So next, for your cylindrical sample, ganun lang din naman ang gagawin natin. So these are just specific measurements. Specific measurements using the same devices that we used previously. So the answers are just here. So again, take note of the uncertainties and experiment 1 techniques. So ito na ang important. So determining volumes and densities. So here we will discuss this in more detail kasi these are more important. So we are actually given here our diameter, lengths, widths, and heights, so and mass. So we can calculate volumes and we can calculate densities. So for this discussion, let's just focus on the cylindrical sample. Since we already discussed rectangular sample volumes in experiment 1's post lab. So let's create a Word file. Document. Okay. So using this data, anong meron natin? Diameter, 25.36 plus minus 0.03. Height, 32.17 plus minus 0.08. Both of these are in millimeters. Our mass is in grams, 138.8 plus minus 0.1 grams. Okay, so again, to determine the volume, let's first recall that the volume of a cylinder is pi r squared h. The radius is simply half the diameter. So we have a diameter and we want to divide it by 2 to get our radius. So let's recall how to do this. So to do this, we go back to experiment 1. So multiplication and division of uncertainties dito tayo. So when a measurement is multiplied by a constant, so the absolute uncertainty must also be multiplied with the constant while the relative value is unchanged. This means that kung gusto natin kalahatiin, we just divide both the central and uncertainty values by 2. So to get the radius, that's simply 25.36 divided by 2 and 0.03 over 2. That's it. So we will get R is equal to 25.36 over 2, 12.68 plus minus 0.15 millimeters. So these are now our given. If we are not sure of whether to use the radius or diameter, we can actually rewrite the volume formula instead in terms of our diameter. So using the relationship between radius and diameter, this is simply just pi d over 2 squared times h. Or we can simply divide this as pi over 4 t squared h. So para wala nang magkakalituhan kung dapat bang i-round off na ito or hindi. And in this case, actually, hindi naman kailangan pa. Ito na lang gamitin natin to be safe. So, using this formula and the given, okay, we calculate the central value of our volume first. So, naka-millimeters naman na tayo. So, the central value is actually just pi over 4 diameter squared, 0.36 millimeters squared, 32.17 millimeters. We should get 25.36 times 25.36 times pi 4159. So 16,249.465 cubic millimeters. So let's keep this central value for now. Next, we want to determine the uncertainties. So this is a case of multiplication and division. So just like with our first experiment, we will have to convert each and every one of these values to relative uncertainties. So let's skip these steps kasi these are experiment 1 steps. So we should get the following relative uncertainties. So again, to get the volume, we'll have to add these relative uncertainties. So the relative uncertainties would be 11.83%. Note that the diameter is squared here, so we add it twice. And the height uncertainty, we add it again. We should get this should be 0.118 pala. We will get 0.485%. So this 0.485% can be converted back to an absolute uncertainty. Kasi we already have 16,249.465 plus minus 0.485%. So the conversion is done as follows. We will get 100%, 249.465. We should get, okay, now we again apply the rules of uncertainty. So gusto nating one significant figure lang si uncertainty. We simply round this off to 80. So yan, okay na siya. And lastly, dapat may significant figure lang si central value hanggang 10th place. So we simply round this off to get 16 to 50 plus minus 80. So now we have our mass, ano nang yung given natin? So we have mass and we have volume. We want to determine the density. So anong given natin? Ni-relative na natin kanina si mass. So that's 138.8 plus minus 0.072%. And V, 16 to 50 plus minus 80. Again, if we convert this to relative, so ano dapat ito? 80 over 16 to 50 times 100. So this is 16 to 50 plus minus. So let's say 492%. So now, mass over volume. The central value is simply 138.8 over 16 to 50. We should get 138.8 over 16 to 50 which is 0.00854 grams per millimeter cube, or simply 8.54 times 10 to the minus 3. Kasi this is 3 decimal places before the first non-zero digit. So next, how about the uncertainty? Again, we add the relative uncertainties. So that is 0.072 plus 0.492. So we should actually get rho is equal to 8.54 times 10 to the minus 3. Plus minus 0.564%. So the last step is converting this to a absolute uncertainty. So to do this, simply again, 564% over what is this 0.564% of? This is 0.564% of your central value. So simplifying everything should give us our density of 8.54 times 10 to the negative 3 plus minus ilan to? 1, 2, 3, 4, 5. So this is again one significant figure. So this is supposedly 5. So 5 times 10 to the minus 4. Or rather 5 pala. Yeah, 5 dapat. So now that we have our density calculation, let's go back to the manual. So nilagyan na natin ito ng answer. So this is our answer for our cylindrical sample, volume, and density. So lastly, let's tackle our questions. So the default uncertainty for an analog device is half the least count, but for digital device, it's the least count itself. Give a possible reason for this. So unang-una, sa isang digital device, wala nang wala nang point of uncertainty. So for an analog device, your least count is between the two smallest measurements available. So for example, dun sa ruler natin, between two lines, actually ganoon din sa sa calipers natin. However, sa digital device, wala na. What you read is what you get. Kaya wala ka makikitang iba na least count niya. So, we skip some calculations, but let's put our density and volume tables here. So for this set, our answer should be this should be our table. So, okay. The density, ang density natin ay in kilograms per cubic meters. So let's first convert these to the same units as our density, or we can do vice versa. So I'll skip the conversion process here, or rather let's do them anyway. So we have, let's use this one for a sige, ito na lang tong cylindrical density natin. So this is grams per cubic millimeter. Okay, how do we convert this? By, so unit conversion, if you remember from your physics 71. Okay, so walang problema dito, magka-cancel lang ito, di ba? Pero itong cubic millimeter nyo, you actually have to convert each millimeter. So you convert your millimeters 3 times. So that's actually 1,000 millimeters over 1 meter. So 3 times mo gagawin yung conversion na ito. So this is basically 1,000, cancel itong dalawa. 1,000 times 1,000 is 1 million. So, ibig sabihin, to get the value in kg per cubic meters, you multiply your answers by 1 million. So, we should actually get 8.54 times 10 to the 3 kilograms per cubic meter. And for our cylindrical sample, in a similar way, so dapat makuha natin ay times 1 million lang din. So that is 2.6 times 10 to the 3 kilograms per cubic meters. And let's not forget the uncertainties pala, which is converted in the same way. So this is 1 times 10 to the minus 4 times 1 million should be to the 2. And for the other sample, it should be 5. Okay. So the density of aluminum is 2.7 times 10 to the minus 3. So malapit siya dito. So ang range natin of absolute uncertainties is plus minus 5. So 2.6 hindi aabot sa density ng aluminum. So our material will not be acceptable for rectangular. And for our cylindrical sample, 8.54 times 10 to the minus 3, ilan ito? This should be 8,540, I think. This should be 100. So, again, given the range of these uncertainties, ang pinakamalayo ko ay 8.44. So, parehong hindi abot ang aking densities dun sa accepted values. So, the results are not acceptable because they fall short of the uncertainty ranges. Accepted values are not in the interval of my uncertainty. So, for the last question, what are the assumptions you've made in obtaining the densities? So, dito yung sources of error natin. So, ang normal assumptions dito ay uniform ang material. That is no air gaps, walang air gaps. Pag sinabi natin uniform ang material, it's pure. Uniform or pure material. Ibig sabihin, walang halo na iba. So, posible rin yun. Pure material. So, ano pa bang ibang assumption? So, isa pang pwedeng assumption ay dapat perfect shape ang cube natin or cylinder. Which means na walang dents or anything na makakapagbago ng shape niya. So, perfect cylinder or perfect cube. So, that's it. So, this concludes our post-lab for experiment 2. So, stay tuned for our upload for experiment 3.